Hi, my name is Todd Artunian. I'm the project manager for the Formula SA Team 2009. Our presentation is going to cover what Formula SA is, cover the team organization, history and goals, the materials used on the car, then it will be followed by the department presentations, followed by a conclusion by myself, a 30-minute intermission where we have snacks in the back, and then we'll open it up for discussions. So what is Formula SE, for those of you that don't know? It's a competition where schools from around the world gather and they test their theoretical knowledge gained in the classroom and use their practical real-world manufacturing skills to build a Formula-style race car. The concepts of the competition are to create a fictional manufacturing firm to build a prototype race car to a non-professional autocross racer. The emphasis is on high-performance acceleration, braking, and handling. This year's competition will be held at California Speedway, June 17th to the 20th. These are our tentative dates so far. The judging criteria has changed a bit. Now, fuel economy is worth 100 points, reducing endurance points to 300. Our total score is still 1,000 points, consisting of static and dynamic events. The team organization is as follows. Dr. Stuart Prince as CEO, myself as project manager, along with 4 crew chiefs in each department, powertrain, chassis, suspension, and controls, and the engineers below them. Our team now consists of 15 team members. The team history is this. CSUN has a great program and a winning car. The past 2 years, in 2007 we placed 7, and in 2008 we placed 12. Our average scores in each of the static and dynamic events have been increasing, especially in the past 2 years, and with an emphasis on increasing the static scores, we hope to continue this trend. With the early finish date of the vehicle, we should allow for a great dynamic score this year. The 2008 highlights, for the 2008 car rather, is a 442-pound wet weight, 11-inch CG height, 48-inch track, 66-inch wheelbase, with a carbon fiber front monocoque, tuned Yamaha R6 engine, titanium exhaust, and pneumatic paddle shifters. This is a 3D model of our 2008 car. Now, the direction of the 2009 team and our team goals. Our #1 goal is to achieve a first place finish. We're going to do this by optimizing last year's design, but not changing the entire concept of the vehicle. We want to increase our high maneuverability and our high engine performance. We also always want to emphasize an increase in power to weight ratio and make manufacturing as easy as possible. Making manufacturing as easy as possible allows us the most testing time to tune the car and prepare for competition. We also want to improve our static and dynamic events to ensure all these goals can be met. So continued on, the high performance aspect of the car is there. We want to focus on high dynamic scoring. We want the high power to weight ratio by constructing a lightweight chassis, and our goal is to have 73 days of testing time. This would allow for more engine and suspension tuning. It will also help us ensure that the car is reliable. Now, although the two combined leave us with an expensive and complex car, if we stick to our goals and stick to our roots, we should have no problem meeting them. Our ingredients for success in the 2019 are scheduling. We have a year-long Gantt chart. Our departments have a 2-week schedule. We also have a delegation of responsibility so that there's no micromanagement of the team. We have the crew chiefs dealing with their individual departments. For good communication, we have weekly crew chief meetings, and we have the departments meeting outside of senior design time to ensure that everybody knows their role and stays on pace. We also want to ensure that our testing time meets our goal. The 73 days is critical for us to succeed and critical for CSUN to get the first place finish that we hope for. We also want to finish design and manufacturing of the car early because we want to practice our presentation skills, and this will in the end help us with our static scoring. Our project organization is this, again, our Gantt chart with the 2-week lead schedules, and each department must submit weekly reports. Our project budget this year is $36,000, and our current budget right now is $15,500, and we're still awaiting our IRA funds. The materials used on the vehicle are aluminum 6061, 7075, 4130 chromoly steel, 4340 chromoly steel, stainless steel, titanium, and lots of carbon fiber. The material specifications are: steel has a good strength to weight ratio, it's inexpensive, and it has a high modulus of elasticity. Aluminum has a great strength to weight ratio, but the modulus of elasticity is a little bit lower. Alloy 7075 has better strength than 6061, but it's hard to find and can get expensive. Chromoly is stronger than steel, but it's more expensive than aluminum. Carbon fiber is a very expensive material, but it has a great strength to weight ratio, but it cannot be machined, it must be molded. Titanium is lightweight, expensive, and the lightweight nature of the material gives us a good strength to weight ratio. This was our materials design matrix. We use this to help us determine what materials can be used in certain areas of the car. Now, it's important to know that 8 points was the highest that each material could get in this category. But again, it's important to know that certain materials may be proper based on the design matrix, but they wouldn't be the best route for us because they could be heavy or make the car overly expensive. Now I'm going to leave you with the department presentation, starting with powertrain. Thank you.